containerization. So we would be talking about what is containerization, what are the benefits of containerization, what is container, what is container image, level of virtualization, and how to run the container. So containerization basically is a method of developing or say deploying and running the software application using the containers. What are containers? Containers are nothing but just like as the name suggests, okay, it contains something. So what it would contain? It would contain your code, it would contain your configuration details, the runtime, and any kind of dependencies that you can have into your application. So why we come towards the containerization concept? Because you might have seen, right, that sometimes the developers say that, hey, it was running good on my computer or my system, why it is not running on yours? So if we want to have the portability into our softwares, okay, into our applications, then in that case, we go towards the containerization approach, which also goes hand in hand with the microservice as well. So how to understand container? So imagine you are moving to a new house and you have lot of possessions that you need to pack and transport. So you can simply load everything into big truck and hope that it all fits. But that would make it difficult to organize and find what you need when you arrive at your new home, right? Now let's consider containerization. Instead of loading everything into big truck, you pack your belongings into separate standardized containers that can be easily stacked and transported. Each container is labeled with its contents, that what is there inside of it, making it easier to find what you need when you arrive at your new home. So similarly, containerization is a technique used in software development where applications and their dependencies are packed together in standardized containers, which can be easily deployed and managed. So each container includes everything which is needed to run the application, such as library dependencies, configuration files, runtimes, etc. So these containers are light-weighted and portable. They can run consistently across different environments such as development, testing, and production. And compatibility issues and dependency conflicts are also reduced over here highly. So you can see containers provide isolated environment for application to run with its own operating system and resources. Right, it makes it easier to develop, deploy, and scale, and it makes it compatible across different environments. So for running the containers, you need the containerization platforms. So that famous platform is Docker. Okay, we don't even say containers nowadays. We always say Docker containers. It is that famous. Okay, so we would be also understanding two different concepts. Okay, one is Docker, another one is Kubernetes. So we would be understanding the difference between two. So let's understand now that what are the benefits of containerization. Benefits of containerization. If you look at first benefit, there are several. But let's see the first benefit, which is portability. Containers can run on any systems, okay, that has the containerization platform installed, which will make it easier to move the application between different environments such as development, testing, or production. So how to run these containers, we would be seeing it very soon, but these are the benefits basically. So it provides you with the portability. You can create one part of your application, run it as a container in any system or any environment. Then the other benefit is consistency. So containers will provide a consistent environment for application to run in, which helps ensure that it behaves the same way across different systems. It doesn't go into any bugs or any unexpected behavior when we are changing the systems. Then we have scalability. So containers can easily be scaled up or scaled down to meet the changing demands, which will allow for greater flexibility as well as cost saving. Second, we discuss about efficiency. So because containers are lightweighted and use fewer resources than traditional virtual machine, it allows us to make efficient use of system resources. Now you will be understanding this when we talk about level of virtualization or abstraction. So virtual machines are hardware level virtualization and containers basically are operating system virtualization. We will be discussing about this soon in our coming slides. Then we have security. So containers provide a degree of isolation and security which helps protect the application from external threats and vulnerabilities. It is becoming increasingly popular in modern software development and deployment. And containers are often used in the conjunction with the technologies such as microservices and orchestration platforms. So from long we are talking about containerization. So the base of containerization or the basic building block of containerization is a container. So container is a lightweight portable unit of software. So it is just like one box into which what I'll put code. What I'll put configuration details. I'll put dependencies. And I'll put the runtime. It packages entire thing, all of these things into one container. And this is the executable package. So it provides isolated runtime environment for application to run in with its own OS, libraries and other resources. Containers are created from container images. Okay. So when we talk about container images, then these are nothing but the blueprints of what all things are required to build a container. It contains everything that you need to run application in the container, such as application code, runtime, system tool, libraries, settings, any kind of dependencies if there. So containers are typically built using containerization platforms such as Docker. Okay, and containers are built from container images. So this is the level of virtualization, the important topic that we have to discuss. You can see in the virtual machine, we have the physical hardware. On the top of that hardware, we run one software called as hypervisor. This hypervisor is responsible for converting our underlying hardware into different virtual machines. So each virtual machine would have its own operating system. Right. Now, let's suppose that I'm having some 1 TB of hard disk. Okay, I have 1 TB of hard disk with me and I have some 500 GB of RAM with me. So these are just the hypothetical number for making you understand. Into the entire infrastructure, this entire infrastructure is having the capacity of 1 TB HDD and 500 GB of RAM. So what this hypervisor will do is hypervisor will be dividing this into different virtual machines. So let's say I'm having one guest operating system of Windows. Here I have Windows. Okay. This can be, let's say, Linux, and this can be Mac. So with this guest operating system, I want for Windows I need let's say 200 GB of HDD, and I need some 100 GB of RAM. Okay, so this would be provided over here. Now let's suppose here I'll just make it 700 GB. Okay. For Linux, if I want 250 GB of HDD, and let's suppose somewhere around 300 GB of RAM. These are just the hypothetical number, again reiterating the same. Now for Mac, I want 500 GB of HDD. That is not possible over here, right? Because I do not have that much of HDD. I have 700 plus 250, 950 GB is already used, and I have just 1 TB of HDD. So here, giving the required resources to Mac wouldn't be possible. So when we are doing the virtualization at the hardware level, we are not able to utilize the resources properly, because the virtualization which is done with the help of hypervisor, it is one heavy job. And each virtual machine is having its own guest operating system, which makes it heavier. Okay, it takes up more resources. So what we want is, that's why we went towards the containerization. So into containerization, what happens is, we have the underlying infrastructure, we have the operating system, and we have container engines such as Docker, let's say. So what this Docker will do is, it will be actually having its own operating system. Over here, you can see that we are having multiple isolated user space instances which are running on single host operating system. Okay, we are having just one operating system over here. So these all containers, okay, they would be sharing the underlying operating system kernel. So host operating system into containerization provides the necessary isolation between different instances or say containers, rather than using a hypervisor or separate kernel for each container. So each container is now becoming lightweight because it is not having its own operating system. So containers would be easier to spin up, quicker to spin up, right? They would be lightweighted, portable and self-contained unit that includes all the necessary dependencies and the libraries required. So resource utilization would be efficiently done as we are sharing the underlying resources, not just CPU and memory, but even the storage. Okay, and also operating system. So because of this, it will be the containers can be easily created, started, stopped or deleted if compared to the virtual machines. So that's about the level of virtualization. So remember this, virtual machines are hardware level virtualization, whereas containers are operating system virtualization. If we want to run container, what we have to do? So we understood that the containers are built from the container images, right? So we have to pull the image from registry. So where we'll get this images from? So there are registries like Docker Hub, or if we talk specifically about AWS, there is ECR, Elastic Container Registry, or we have Docker Hub. So we have multiple images on the Docker Hub available publicly, or we can create our own image and put it on Docker Hub or ECR. So once we are creating this particular image, okay, we have to pull that image. We will be storing that image in those registries. So if we want to create the containers, we have to pull the images from the registry if they are already created. If not, we can create an image and put it into the registry. that image, we can create the container. And lastly, we have to manage the container. So for managing these containers, we have Docker. Individual container can be managed by Docker. If we want to see at the higher level or the broader picture, then we would be using the Kubernetes. We would be explaining, or we would be understanding about that as well in the coming slides. So now we have container services on AWS. So let's get started with this one. But before to that, I just want to add one more thing over here. So I think that for creating this image, okay, we need one Docker file. So Docker file is nothing but a text file that will contain the instruction to create the Docker image. Because we understood that image is nothing but it has everything, right? From application code to dependencies to configuration details, right? So all these things are being mentioned in the Docker into the Docker file as instruction. So it is essentially a script that describes the steps necessary to create the container image. Okay. So that's one thing that I wanted to add over here while running the containers.